If you keep on explaining, if you keep on doing the L'Hospital's rule, then what will happen if you differentiate e power x into derivative of sin x? So e power x into cos x plus sin x into derivative of e power x sin x. The terms are going to be increased. The terms are going to be increased. That's why what I'm going to do is I'm going to substitute the expansions yes and do simplify it. And then on substituting those things, then definitely you will get something very easily within two steps itself. So I'm substituting x tends to 0. E power x expansion is 1 plus x by 1 factorial plus x square by 2 factorial plus 1 or x cubed by 3 factorial plus 1 multiplied with the sin x minus x cubed by 3 factorial plus x power 5 by 5 factorial minus 1. Sort it all finished. Again, minus x square. Minus x square. All divided by x square plus x. X square plus x into log of 1 minus x to the basic. Minus x square by 2 minus x by 3 minus x power 4 by 4 1. So if you do simplify this, both in the numerator and denominator you will get the answer. If you do simplify this, let's cancel. X into x square minus x square, both gets cancelled. So what is the next step? Here in the numerator, what you are getting? What you are getting? Limit x tends to 0. One into minus x cubed by 3 factorial. So minus x cubed by 3 factorial x into x square by 2 factorial plus x cubed by 2 factorial. Again, x into x power 3, that is x power 4 into something plus x power 5 into something and so on. All divided by here x square minus x square. X square minus x square. Both get cancelled. So minus x cubed by 2. And minus x power 4 by 3. And minus x power 5 by 4. And so on. So it is very clear now. Very clear you are going to get the answer. What is the answer? This is equal to X cube can be taken common in the numerator, and also x cube can be taken common in the numerator. That x cube gets cancelled. So we are getting minus 1 by 3 plus 1 by 2 factorial. Okay, divided by minus 1 by 2. See, observe it carefully. X cube taken common among these two terms. So 1 minus 1 by 3 factorial plus 1 by 2 factorial. Here x cube taken common minus 1 by 2. Here, after taking x cube common here in the numerator and in denominator, both x cube gets cancelled. So some constant into plus x into something, x square into something, and so on. Here also minus 1 by into minus 1 by 2 minus x by 3 minus x square by 4, so on. On substituting x equals to 0, so everything will become 0. The only answer is minus 1 by 3 factorial plus 1 by 2 factorial minus 1 by 2. So the answer is this one. This is equal to 1 by 2 minus 1 by 6 by minus 1 by 2. So the answer is here 6, and this will become 2 3s. 3 minus 1. That is 2 by 6. 2 by 6 by minus 1 by 2. So 2 also gets cancelled. So the answer is minus 2 by 3. Please note down. So the problems which are getting the derivatives recurrently. Recurrently means repeatedly, even after doing the L'Hospital's rule. Then what you have to do is substitute those expansions. Sin x, e power x, log of 1 minus x, and all these. On substituting this, within 1 or 2 steps, you are getting the answer. Everybody got this? Say yes or no, message it. Yes. So if you have written, I'll give you 2 more simple formulas related with the limits or the exponential form limits. It's okay now. Right, let's do more simple formulas related with infinite limits as well as the exponential. Limit n tends to 0, 1 plus um, 1 plus n whole power 1 by n is equal to, please note down, limit n tends to 0, 1 plus n whole power 1 by n. Similar 1 plus n, whatever we are writing here as positive plus to this, that should be very small. I'm not saying 0, tends to 0. And this is 1 by n. Here, n is reaching to 0. N is reaching to 0. Okay, this must be equal to E. E has a value of 2.71 something else. Do remember? E has a value of 2.71 something else. And the same limits equals to infinity 1 plus 1 whole power n is equal to E. Is it clear now? How to remember this? Whatever the value 1 plus something is there, that should be very small. Okay, like 0.001, like. And when you are writing 1 by 0.001, so that will be so large. The power of this expression must be infinity. When the power of this expression is infinity, so this is very 1 point very small value. Whole power infinity will be E. E has a value of 2.71 something else. Okay. And the same thing here also you can write. As n tends to infinity, 1 by n will be very small. And whole power infinity. In the power should be the reciprocal of this value which we are adding to 1. And whatever we are adding to 1, it must be very small. And whatever the power is there, it must be very large, so large. Okay. So these two formulas are very important. We based on these, the people have got very simple questions previously. So let me write one question. Limit n tends to infinity 1 minus 2 by n 1 minus 2 by n whole power n. Tell me the value of it. Make it quick fast. Yes, what is the value? Can somebody say what is the answer? Yes. So it is similar to this one. So what I am going to do it is limit n tends to infinity 1 plus minus 2 by n. 1 plus minus 2 by n whole power. As we are having n here, I am going to write reciprocal of this n by minus 2. So if we have written n by minus 2 whole power minus 2. Minus 2 gets cancelled. So what is the value now? Whole power n only. Whatever we have written here, reciprocal is there in the power. So as per the limit formula, limit n tends to infinity, 1 plus minus 2 by n whole power minus n by 2 whole power minus 2. This is the thing. Whole power minus 2. If you do simplify, see, there is a constant that extends to a f of x whole power n is nothing but limit extends to a f of x whole power n. Divide the power with the entire limit. So n tends to infinity is just like that of the second one. 1 plus minus 2 by n. So n tends to infinity means minus 2 by n also tends to 0. The reciprocal of it is there in the power of it. The reciprocal of it is there in the power of it. So whole power minus 2. It is just like it n tends to infinity 1 plus 1 by n whole power n. Whatever we have written as 1 plus, the reciprocal is there in the power. So therefore that is nothing but e. So if we are having here the n tends to infinity 1 plus minus 2 by n whole power minus n by 2 whole power minus 2. The entire value inside the disk is nothing but e whole power minus 2. Is it clear? Please send me the message. Is it clear? Say yes or no. Yes or no. Send me the message quickly. Are you getting my voice? Is it clear now? Right. By using the application of the expansions of the trigonometric functions and this formula. Let me do one more problem. Limit x tends to 0 sin x by x whole power 1 by x. Limit x tends to 0 sin x by x whole power 1 by x. Here in the power, we are having infinity. So you know the expansion of sin x. Try to use expansion of sin x, or otherwise you have to consider this entire as some function of x, and you need to bring this 1 by x before to that by applying logarithm. Instead of that, writing sin x expansion is better. This I am going to write it as limit x tends to 0. Sin x expansion is x minus x cube by 3 factorial plus x power 5 by factorial minus 1 whole divided by x whole power 1 by x whole power 1 by x. This is equal to. So what I am doing is here, I am going to take x common, the numerator, and cancelizing this denominator x. So you are getting limit x tends to 0. If you take x common and get cancelled with the denominator, that is 1 minus x squared by 3 factorial plus x power 4 by 5 factorial and so on. Whole power 1 by x. Whole power 1 by x. So here, what I am going to do is, I am trying to take common x among all of these, because we are having 1 by x in the power. So this is equal to limit x tends to 0, 1 plus x into some t whole power 1 by x whole power 1 by x. And I'm going to write what is that t. As I have written t here, I am going to write t in the denominator also, dx. And again I am writing whole power t. Now t gets cancelled. What is this t? Where t equals to Among all of these, I have taken x common. So the x taken common is equal to minus x by 3 factorial plus this is x cube by 5 factorial minus 1, where t equals to this one. T equals to this one. Okay. Now 1 plus dx whole for 1 by dx whole for t. If you cancel this t, you will be getting only 1 by x. If you substitute that t value here, this t here, you will be getting the same thing. Okay. So now, as x tends to 0, tx also tends to 0. If x tends to 0, tx also tends to 0. Come on, tell me what is it? Limit dx tends to 0. 1 plus dx whole for 1 by dx whole for t. Limit n tends to 0. 1 plus n whole power 1 by n. So this is equal to e power t. E power t as x tends to b. E power t as x tends to 0. Already you know what is t. When x tends to 0, what is t? T also tends to 0. E power 0 equals to 1. Since t tends to 0 as x tends to 0. So the answer is 1. Is it clear now? Is it clear? Is it clear or not? Send me the message. Say yes or no. Are you getting my voice? Next one, write down next one. Limit X tends to 0. Tan x by x whole power 1 by x square is in the power of that. You need to know what is the expansion of tan x. What is tan x expansion? Tan x is equal to, but tan 0 is 0. So the first term will be 0. There is no constant. So derivative of tan x is secant square x. So you will get x plus x cube by 3 plus, how to find the expansion of tan x I'll explain later. As for this problem, just go ahead. In mean value theorem, we are going to find how you are going to get these expansions. E power x, sin x, cos x, sin hx, cos hx, tan x, tan inverse x, sin inverse x. All these expansions we will write. Okay. So x plus x cubed by 3 plus 2 by 15 x power 5 plus so on. This is tan x expansion. Please go down. Now use this substitution or that. If you write x tends to 0, tan 0 is 0, 0 by 0, whole power infinity. It is an indeterminate limit. It's just like 0 by 0, whole power infinity. Now I am going to write limit x tends to 0, tan x expansion. X is less x cubed by 3 plus 2 by 15 x power 5 plus so on. All divided by x. Whole power by x squared. This is the problem given to us. Now, if you take x common among all the numerator terms, what is happening? Limit x tends to 0. I have taken all x terms. X taken common among all the numerators. X cancels to the denominator. So you are getting 1 plus x squared by 3 plus 2 by 15 x power 4 plus so on. Whole power 1 by x squared. Now among all of these, as the power is containing 1 by x squared, I'm going to take x squared common. As the power is having x squared, I'm going to take x squared common. Limit x tends to 0, 1 plus x squared into t, whole power 1 by t x squared whole power 9 t x squared. Since I have written t here, you may write whole power t. This t gets cancelled. What is that t? What is that t? Where t equals to, among all of these, I have taken x squared common. T equals to now what? 1 by 3 plus 2 by 50 x squared plus 1. This is t. This is t value. Is it clear? Now you can say the answer. Please tell me the answer quickly. Make it fast. Make it fast. Tell me the answer. It's finished. Can somebody say what is the answer? Please tell me what is the answer. Everything I have written on the board, and just you have to follow the previous problem sequence. And you need to say the answer, that's enough. What is the answer? No response. Quick, quick. As I have written, limit x tends to 0 means 3x square also tends to 0. Whole power infinity. Okay, so the entire value inside of this will be this entire is nothing but whole power t as x tends to 0. Power t as x tends to 0. Okay, so this is equal to, as x tends to 0, t tends to 1 by t tends to 1 by 2. So this is nothing but power 1 by 2. This is the answer. T tends to 1 by 3. Is it clear? Say yes or no. Please somebody write a message. Is it clear or not? Is it clear? So this type of problems you can expect in the examination, and these were also asked previously. Now let us go ahead with the next topic in this ordinary calculus, mean value theorems. In mean value theorems, we are having primarily 5 mean value theorems. But all the mean value theorems are interlinked. If you know the fundamental mean value theorem, that is Lagrange's mean value theorem, then one by one you can easily remember and you can easily write all the mean value theorems. Okay. Let us write the heading mean value theorems. Mean value theorems. Mean value theorems. Write down first one, Rolle's theorem. Rolle's theorem. Rolle's theorem. Rolle's theorem. If f of x is continuous over closed VAB, if f of x is continuous over closed VAB, f dash of x and f dash of x exists for all x in opening AB. Also, f of A equals to f of A equals to f of B. Then there exists at least a value such that f dash of C equals to 0. Such that f dash of C equal to 0. I repeat this statement once again. Already we have discussed about the continuity over closed VAB. Closed interval means it looks at n values a and b. It is continuous means simply you need to understand the function is very much finite for all the values in between a and b. Start with f of a. F of a is finite. F of b is finite. And function values from f of a to f of b all are finite. If there is any point in between a and b at which it is not defined or infinity, it is not defined or infinity, then you have to consider them as not continuous means starting from A to B. All the points, it is very much finite, right? And f dash of x exists means it is differentiable. First dash means one dash means first time. Once it is differentiable. Okay, the derivative of the function is existed in between a and b. Not at the endpoints, but in between them you can differ it. Differ means here is a pen, not at the endpoints. In between them, you can separate. So this is differentiability at this point. This is differentiability at this point. Okay. So what you can say, it is differentiable not at B and not at A, but between them is purely differentiable. You can separate it. Right. After that, the function value at the endpoints must be equal. If the function value at the endpoints are equal, then only you can say that it is Rolle's theorem. Then definitely there will be a point in between A and B. Not A, not B, but in between A and B. Satisfying f dash of C equals to 0. This is known as Rolle's theorem. This is known as Rolle's theorem. Let us do a problem related to this or based on it. Write down a problem. For what value of x? For what value of values of x between 0 and 5. Between 0 and 5. Does the function f of x equals to sin x by e power x? Sin x by e power x. Satisfies Rolle's theorem. Satisfies Rolle's theorem. Satisfies Rolle's theorem. I'm going to give you the options also. Minus 5 by 4, 5 by 4, 5 by 4, 9 5 by 4. Have you written? Have you written or not? Now, how to verify the continuity? Continuity between 0 and 5. So, sin x is continuous for all the values in between 0 and 5. E power x is also continuous. That means sin x is finite and e power x will never be 0 for all the values in between 0 and 5. Please write e power x not equal to 0 for all x and close 0 gamma 5. Close 0 gamma 5. Therefore, Therefore, the function f of x is finite for all x in closed 0, comma 5. For all x in closed 0, comma 5. And therefore, it is continuous over closed 0, comma 5. So continuity is finished. The next one is differentiability. Or before that, just write f of 0. What is f of 0? Sine 0 by e power 0. Sine 0 by e power 0. 0 by 1 equal to 0. And f of pi is sine pi by e power pi. That is our sine pi is 0, e power pi is not equal to 0. So f of 0 equals to e of pi. Now you may find f dash of x. F dash of x is u by the formula e power x into derivative of sin x cos x minus sin x into e power x divided by e power x whole square. U by the formula u by d into derivative of sin x minus u into derivative of denominator divided by denominator whole square. So here this is f dash of x. Now as e power x not equal to 0, e power x square also not equal to 0. So therefore it is purely existed or finite. Exists since e power x whole square not equal to 0. E power x whole square not equal to 0. Whatever the value of x that it may be, e power x whole square will be 0. Now denominator is not equal to 0. So the numerator must be 0. Numerator must be, this must be, there exists a point C in between A and B satisfying f dash of C equal to 0. So f dash of C, what is f dash of C? F dash of x. This is already existed and you have to equate this to 0. So this is equal to this is equal to 0. This is equal to 0. So this implies denominator is not at all 0. Numerator must be 0. E power x is not 0. So this implies you can say cos x minus sin x equals to 0. Implies cos x equals to sin x. Cos x equals to sin x. Now tell me for what value of x between them is it satisfying? For what value of x between them is it satisfying? Is it minus pi by 4, pi by 4, 5 pi by 4, 9 pi by 4? Yes, tell me quick. Yes, tell me quick. See, actually here, I'll give you the explanation for all of this. 5 by 4 means it is in the first quadrant. This is 0, 5 by 2, 5, 3, 5 by 2, and this is 2 pi, 2 pi. So here we are getting 5 by 2. Okay. Now what you can say? 5 by 4 is lying in between 0 and 5. You can take 5 by 4. And minus 5 by 4, it is not lying in between them. So option A is not correct. Option B may be correct. 5 pi by 4 means 5 pi by 4 means 5 plus 5 by 2. This is 5 pi by 4. If you come across the first quadrant and second one plus this, 5 plus 5 by 4 will be 5 pi by 4. Cos x equals to sin x for 5 pi by 4 also. Cos x equals to sin x for 5 pi by 4 also. Because sin is positive in the first quadrant and second quadrant. And the sin and cos both are negative in third quadrant. So at 5 pi by 4 also both are equal. But it is not lying in between 0 and 5. It must lie in between 0 and 5. What value of x? Between 0 and 5. This is the meaning. 5 pi by 4 at 5 pi by 4 also cos x sin x both are same. But this 5 pi by 4 is not lying in between 0 and 5. And where is 9 pi by 4? After making one circulation, it will be completing 2 pi, and 2 pi plus 5 by 4 will be 9 pi by 4. Okay. At 9 pi by 4 also cos x equals to sin x, but it is not lying in between 0 and 5. Please note down, cos x equals to sin x satisfies for 5 by 4, 5 pi by 4, and 9 pi by 4. Satisfies for 5 by 4, 5 pi by 4, and 9 pi by 4. But 5 pi by 4 and 9 pi by 4 are not lying in between 0 and 5. 5 pi by 4 and 9 pi by 4 are not lying in between 0 and 5. So therefore, only for 5 by 4, Rolle's theorem is satisfied. Rolle's theorem is satisfied by the function f of x equals to sin x by e power x between 0 and 5. Between 0 and 5. Tell me, is it clear or not? So yes or no? Say yes or no. Somebody please send the message. Then I'll move on to the next theorem. Please write. Please send the message. Quick. Is it clear? Is it clear? Is it clear or not? Right, the next one. Lagrange's mean value theorem. Lagrange's mean value theorem. I think you are also having difference. Lagrange's mean value theorem. This is also known as fundamental mean value theorem. Lagrange's mean value theorem. This is also known as fundamental mean value theorem. So it is very clear the first two topics or first two conditions. Continuity and closed interval, differentiability or open interval are same for this also. Right now, please. Of X is continuous over and f dash of X exists for all X in open AB, then there exists please a value C in open AB that f dash of C equals to f of B minus f of A by B minus A. Please note down f dash of C equals to f of B minus f of A by B minus A. Is it clear? So we have observed both the conditions in Gauss theorem also. And if f of A equals f of B, that will be 0. Actually, Rolle's theorem is modification of Lagrange's mean value theorem. Okay. Rolle's theorem is nothing but the modification of Lagrange's mean value theorem. Is it clear? If f of A equal to f of B, then definitely you can say f dash of C equal to 0. So therefore, it is clear Rolle's theorem is an application of Lagrange's mean value theorem. So that's why we call this Lagrange's mean value theorem as fundamental mean value theorem. Right. And we can write another form of definition for this. Please note that one also. Here, I am going to write one simple thing. In this, I am going to take B equal to A plus H. And I'm saying B equal to A plus H. So H will be B minus A and C equals to A plus theta H. Now, theta will be lying in between 0 and 1. If you want to write B minus A, H is 1 now, B minus A. I'm saying C is lying in between A and B. C is in between A and B. If C is equal to A, so theta will be 0. If C equal to B, B minus A will be H. H gets cancelled. Theta will be 1. Once again, I repeat, I'm going to modify the same statement by taking the substitution B equal to A plus H and C equals A plus theta H. Then we are not going to say about the C. We will tell about the value of theta. So the one simple modification is write up or if f of x is continuous over closed A comma A plus H. Why am I writing this modified form? Because this modified form is nothing but what? This modified form will lead you to Taylor's theorem. From that we can write Taylor's series. From that we can write the expansions. So that's why I'm writing this modified thing. And for all the remaining theorems also, Rolle's theorem linked with Lagrange's. Next one, Cauchy's mean value theorem linked with Lagrange's. Next one, Taylor's theorem linked with Lagrange's. Next one, Maclaurin's theorem linked with Lagrange's. So that's why we call Cauchy's mean value theorem fundamental in-value theorem. For an examination, if you have asked only mean value, definitely you have to consider only this. So f of x is continuous over this, and f dash of x is from x open A comma A plus H, open A comma A plus H. Then there exists at least a value. Then there exists at least a value. Theta n open 0, 1. Theta n open 0, 1 such that then there exists at least a value theta n open 0, 1 such that f of a plus h equals of a plus f of a plus h into f dash of a plus sigma h. H into f dash of a plus theta h. Everybody have it? Either this or this. Both are same. Both are nothing but fundamental mean value theorems or Lagrange's mean value theorems. Now, let you write a problem. Let you write a problem. For what value or values of x? What value or values of x? Between 0 and 4. Between 0 and 4. Does the function f of x equals to x minus 1, x minus 2 into x minus 3, x minus 1 into x minus 2 into x minus 3 satisfies mean value theorem. Mean value theorem. So here, what is f of in -1, -2, -3? It's very clear, -6. What is f of 4? 4 minus 1, 3. 4 minus 2, 2. 4 minus 3, 1, 6. Both are not equal. So therefore, you may verify Lagrange's mean value. Next, f of x is continuous. So substitute any value in between 0 and 4, definitely it will be continuous. Please write that. For any value between 0 and 4, for any value between 0 and 4, for any value between 0 and 4, the function f of x is finite. Finite. Therefore, it is continuous over closed 0, 4. Therefore, it is continuous over closed 0, 4. Next, you have to find f dash of x. So before writing f dash of x, I'm going to write f of x like this. X minus 1 into x square minus 5x plus 6. This I have multiplied this one and this one and written x minus 1. So now f dash of x is x minus 1 into 2x minus 5 plus x squared minus 5x plus 6 into derivative of x minus 3 is 1. So this is equals to 2x into x. 2x squared plus x squared. 3x squared minus 2x minus 5x minus 7x minus 5x. minus 12x plus 5 plus 6 plus 11 plus 11. Is it existed or not? You take any value in between 0 and 4 in this, definitely it will be finite. Exists. Now, what do you have to do? If it satisfies Lagrange's mean value theorem, there must be a point in between 0 and 4. Minimum one value between 0 and 4. Satisfying what? F dash of x equals to f of a minus f of a by b minus c. Now you substitute that in f of b minus f of a by b minus c. Solve it. If you are having any value x between 0 and 4, then you can say it is satisfying like that. Yes. So this is existed. Now I am equating it to f of 4 minus f of 0 by 4 minus 0. This is equal 6 minus of minus 6 by 4. Nothing but 3. So we bring this towards left. 3x squared minus 10x plus 8 equal to 0. Plus 8 equals to 0. Now if you solve this, x is equal to, I'm using quadratic equation, roots of the quadratic equation. Minus b, that is 12 plus or minus root of b squared, 144 minus 4 AC, 4 into 3 into 8, 96 by 2 into 3, 6. This is equal to 6 twos, 2 plus or minus. This is 48. Root 48 by 6. Root 48 means 6.9 something divided by 6. If you simplify this, then 6.956 will be 1.15 something. So 2 plus 1.15 will be 3.15 something, comma 2 minus 1.15 will be 0.84. 0.84. So if you are having both in one option, you have to choose that. If you are having only one in one option and another in another option and both in another option, you have to choose the option. You have to choose the option containing both. Say if A is 3.15, B is 0.84, C is both A and B, D is none. So which one is the answer? Which one is the answer? Tell me now. Which one is the answer? Tell me now. Everything I have explained, I'm asking you which option is correct. I have written both is correct. The option containing both. Somebody please write the message so that I can assume that you people are not sleeping. Somebody please write the message. You have to choose the option containing. You have to choose the option containing both. Both. C, both A and B. So it is clear. So it is clear. Send me the message. Send me the message. Now write down the next problem related to the mean value theorem which was given in previous examination. Write down. A rail engine a rail engine starting from horizon traveled a distance of 380 meters. 380 380 meters. 380 meters in 8 seconds. 380 meters in 8 seconds. In 8 seconds. Then by mean value theorem, what is the reading in its speedometer? What is the reading in its speedometer? What is the reading in its speedometer? In its speedometer. What is the reading in its speedometer? By mean value theorem, the initial point or the horizon means 0. Starting at 0, within 8 seconds, it has traveled a distance of 380 meters. 380 meters. 380 meters. Have you written the question? Please respond. Have you written the question? Have you written the question? Please respond. Have you written the question? Please respond. Yes. A rail engine, R-A-I-L-N-G-I-N-E, a rail engine starting from origin or stationary point, starting from origin or stationary point, travel a distance of 380 meters, travel a distance of 380 meters in 8 seconds, 8 seconds, 8 seconds. Then by mean value theorem, I'm not mentioning the name. In the question also, they have not mentioned the name. They ask by mean value theorem, what is the reading in its speedometer? In rail engine speedometer, what is the reading that you have to say? That's enough. Okay, by mean value theorem, our starting point A is 0. Stationary point means A is 0. What is the time? B is 8 seconds. So at 0, that distance is f of 0 is 0. Stationary point is again 0. At 0 seconds, it has just started. So f of 0 will be 0. And at 8 seconds, f of 8 will be 380 meters. It is nothing but 380 meters. Now what you will do? Here, what you will do? A is 0, B is 8, and f of 0 is 0, stationary point. And f of 8, at 8 seconds, it has traveled a distance of 380 meters. This is 8 seconds. 8 seconds. Do remember seconds. Now, by mean value theorem, f dash of at 8 seconds, what is its reading? The speed is nothing but speed equals to, by mean value theorem, speed equals to the derivative of it with respect to time. Derivative of the distance with respect to time. That is f of 8 minus f of 0 by 8 minus 0. F of 8 minus f of 0 is 380 minus 0 by 8. So 380 by 8. Meter per second. It is meter per second. But the speedometer in rail engine or speedometer in any of the engines or in any of the moving vehicles, cars, buses, or trains, or motorcycle, whatever it may be, they will show the reading in kilometer per hour, not in meter per second. That kilometer, you have to mention kilometer per hour. How to write this in kilometer per hour? Yes, 385 into kilometer per hour. 1 kilometer is equal to 1000 meters. 1 hour is equal to 3600 seconds. So kilometer per hour means you have to multiply that with 3600 by 1000. That is 18 by 5. If you multiply this with 18 by 5, then it will be mentioned in terms of kilometer per hour. So this is 8, 4 times 9, and 4 is nothing but 5, 5 sevens, 35, 30, 5, 6. And 4, how many times it cancels this one? 14. 14, what is this? What is the value? Tell me now quickly. Is it to be multiplied with 18 by 5? Three 18 by 8. In order to say that meter per second in kilometer per hour. So what is the value that you have to do? You have to multiply with, you have to multiply with 18 by 5. Yes, tell me now quickly. So calculation, yes, go. We can keep there. What is the answer? Yes. Huh? 171. Very good. Can somebody say the answer? Kilometer per hour, meter, so then, yes, I have just given you one simple calculation. You are not saying anything. Come on. Then our problem and check 380 and plus. Somebody please tell me the answer quick, fast. 71 is also same the same. 71. నేను ఏమి ఇవ్వాలన్నా 9 seconds 14 కావాలి. 380 అంటే 280 minutes. So have you got 171? So if you want to see the speed in those speedometers, correct. 171 is correct. Everybody got the same 171. 171 kilometers per hour. Actually, in the question it was asked the 280 meters, but I have changed it into 380 because now the government of India is introducing Vande Bharat super faster sleeper trains, which may travel maximum of up to 180 kilometers per hour. Okay, but that 126 will be was the answer of 280 meters. If it is 280 meters, 126, that was the maximum speed attained by the Rajdhani Express in India. Okay, so 171 kilometer per hour. So if you want to convert meter per second into kilometer per hour, multiply with 18 by 5. You should not say the answer in meter per second. You have to say the answer in kilometer per hour. 171 kilometer per hour. Next write down Cauchy's similarity. Cauchy's similarity. It is nothing but the generalization of Lagrange's mean value theorem for two different functions over the same interval. Two different functions over the same interval. Right now, if f of x comma g of x are continuous over PSDAV are continuous over PSDAV and f dash of x comma g dash of x exists for all x in open AB. For all x in open AB. For all x in open AB. Open AB. Such that g dash of c not equal to 0 or g dash of x not equal to 0 and g of b not equal to g of a. G of b not equal to g of a. Then there exists at least a value. At least a value. C in OpenAB.
Center.
Extraction
Real
of
was
C, G dash of C equals to f of p minus f of
కొంచెం తక్కువ చదువు
g of p minus g of a. G of p minus g of a. Now it is nothing but the generalization of Lagrange's mean value theorem for two different functions. Lagrange's mean value theorem is studied only for one function, f of x continuous, f dash of x exists, and there is at least a value c satisfying f dash of c equals f of b minus f of a by b minus. I am writing it for two different functions. What are those two? F of x and g of x. Same thing. So I'm writing one function f of x, I have written both. Then there is at least a value c in open here is satisfying. If it is only one function, f dash of c equal to f of b minus f of a by b minus c. And even if you substitute g dash of c also, g of b minus g of a by b minus c. B minus a, b minus a gets cancelled. So you are getting this. This is Cauchy's mean value theorem. Now the important thing is, while you are writing any statement, whatever the function you are writing in the denominator should not be 0. It must be not equal to 0. It's very, very important fundamental principle that you need to remember. Even while you are doing any project or any kind of research, the denominator should never be 0. That has to be written in the theory. So that I have written here. That's enough. It is just like that of a small quantity of salt or table sugar. So you are adding it to the table contents. So without these two, it has no meaning. You cannot write the statement without writing these two. Right. Let me do a problem. Write down. Let me do a problem. Verify Cauchy's mean value theorem. Verify Cauchy's mean value theorem. Cauchy's mean value theorem. Cauchy's mean value theorem for the functions sin x comma cos x over closed AB provided their derivatives exist provided their derivatives exist for all x in open AB. For all x in open AB. So what you have to do is, this is f of x and this is g of x. If that verify Cauchy's mean value theorem. Verify Cauchy's mean value theorem for the functions sin x comma cos x over closed AB provided 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 their derivatives THEIR derivatives DERIVADES derivatives exist for all x in open AB. For all x in open AB. So consider sin x as f of x and cos x as f of x. And write the problem. Derivatives exist and not equal to 0. And not equal to 0 for all x in open AB. Now simply you can say sin x is continuous, cos x is continuous. Because their derivatives are existed. If a function is differentiable, it is continuous. Okay, in the beginning we have discussed related with the limit continuity. Now, f dash of, we need to find a value c in between a and b. Between a and b, we have to find a value c, satisfying f dash of c by g dash of c. So f dash of c is what? F dash of x is cos x, g dash of x is minus sin x. It's about the derivatives. Okay. Now f dash of c by g dash of c is equal to cos c by minus sin c is equal to f of b minus f of a. F of b is sin b minus sin a by cos b minus cos a. The only thing is, if you know the transformation formula, you can say the answer. This is equal to sin b minus sin a. 2 cos b plus a by 2 sin b minus a by 2 divided by cos b minus cos a minus 2 sin b plus a by 2 sin b minus a by 2. So sin b minus a by 2 gets cancelled, 2 gets cancelled. So c equal to b plus a by 2. Tell me now, c is lying in between them or not? Is the value b plus a by 2 lies in between a and b or not? Say yes or no. Does it lies in between them or not? No response. B plus a by 2 is arithmetic mean. The arithmetic mean of two numbers always lies in between them. So it is lying in between A and B. So therefore, Cauchy's mean value theorem is satisfied. Please write. Say yes or no. A plus B by 2 is the arithmetic mean of A and B. So the arithmetic mean of two numbers always lies in between them. Why is it? The arithmetic mean always lies in between them. So it satisfies Cauchy's mean value theorem. Let us move into the next very important one, Taylor's theorem. Taylor's theorem. If of x, f dash of x, f double dash of x, so on, n minus one derivative of x are continuous or close Real gamma by equal stage, and the nth derivative of f of x exists for all x in open Real gamma equal stage. Nth derivative of f of x exists for all x in open Real gamma equal stage. Then there exists at least a value theta open 0, 1 such that f of a plus h equals to f of a plus h by 1 factorial f dash of a plus h square by 2 factorial f double dash of a plus 1 plus h power n by n factorial nth derivative of f of a plus theta x. Let's note down that it will first. F of a plus h equals to f of a plus h by 1 factorial dash of a plus h square by 2 factorial f double dash of a plus so on h power n by 1 factorial f derivative of f of a plus theta h. This last term is known as Lagrange's form of remainder. Lagrange's form of remainder. Lagrange's form of remainder. Why we are using Lagrange's? Because this is nothing but the extension of Lagrange's mean value theorem. See, if you write a note, the most important thing is if If you are taking n equals to 1, that means the first derivative. If you consider n equals to 1, then f of x is continuous over a plus h. And f dash of x exists over open a plus h. Then there is at least a value in 1.01. Satisfying. F of a plus h equals to f of a plus, put n equals to 1 in the last term. H by 1 factorial f dash of a plus 6. That's enough. Okay. Write down note 1. Taking n equals to 1, the Taylor's theorem. N equals to 1, the Taylor's theorem. It is reduced to Lagrange's mean value theorem. It is reduced to Lagrange's mean value theorem. It is reduced to Lagrange's mean value theorem. So therefore, Taylor's theorem is known as generalized. Taylor's theorem is known as generalized mean value theorem. Generalized mean value theorem. Normally. So, this is known as generalized mean value theorem. Okay. Now I am going to write Taylor series from this. This is very important. Taylor's series. Taylor series means as n tends to infinity, note down. As n tends to infinity, in the above Taylor's theorem, the remainder Rn equals to h power n by n factorial, nth derivative of f of a plus theta h. The remainder Rn equals to h power n by n factorial, nth derivative of f of a plus theta h. Amma, you have to say now, is it equal to 0 or tends to 0? Is it equal to 0 or tends to 0? Tell me quick. Is it equal to 0 or tends to 0? There's a lot of difference here. If you write this is equal to 0, if you write this is equal to 0, here is a common general mistake that you did not do. If you write equal to 0, then this series will contain only finite terms, which is wrong. As n tends to infinity, this tends to 0. Tends to 0 has a lot of difference. Like a person is dead. If it is equal to 0, person is dead. The person is no more. If it tends to 0, person is going to die. Like everybody. Okay. So when you consider that a person is going to die, that person is always thinks that he has infinite life. That's why we people are doing all these things. The people used to do BTech, MTech, PhD, and then doing some business, and then earning money, and so on. Okay. So if we think that if it is equal to zero, we are going to die the very next day, nobody will do anything. So everyone are thinking that their life is infinite. That's why they are reaching towards that death. It is not equal to zero. If it is equal to zero, it is finished. So everyone has to think that we may reach someday, but when? After infinite number of days, or after infinite number of at least weeks. So that's why then we get what we are getting. F of a plus h equals to f of a plus h by 1 factorial f dash of a plus h squared by 2 factorial f double dash of a plus so on plus so on. That's enough. So on. That's enough. It's an infinite series known as Taylor series. So on. An infinite series known as Taylor series. So why I said that Taylor series is infinite? Why I said that it's is equal to zero means it is fixed. You will be getting only finite series. But Taylor series is not finite, it is an infinite series. Like everybody, every human being on this earth has to think that their life has infinite life. Okay, if you don't think that your life is infinite, you will stop doing the work from that day onwards. So everybody has to think that your life is infinite. That's why we have to do all this, and we need to prepare for GATE, and we need to do the MTech or doing job, earning money, and so on, so on, so on. So that's it. Okay, so therefore, Taylor series, nothing but an infinite series. Infinite series. Okay. So yes or no? Now, based on Taylor series, are related to this. I am going to take a substitution. Put a plus h equals to x. Don't change a. Just change h equals to x minus a. Then you will be getting a modification of Taylor series. Modification of Taylor series. And I note. A note. Taking a plus h equals to x. Then the Taylor series is f of x equals f of x equals a plus h equals to x. F of a plus x minus a by 1 factorial f dash of a plus x minus a whole square by 2 factorial f double dash plus on plus on. David got? Wait, is that's not the father was right. So this is another form of Taylor series. Let us quickly finish the Maclaurin's theorem and Maclaurin series. They are nothing but the modified forms of Taylor's theorem and Taylor series. Please note it. I'll finish it in 2 minutes, not more than that. Write down Maclaurin's theorem. He called. Please. Maclaurin's theorem. I'm just writing directly from the Taylor's theorem. Write down Maclaurin's theorem. Maclaurin's theorem. Maclaurin's theorem. Actually, you're supposed to write like this. Maclaurin's theorem. In the above Taylor's theorem, taking h equals to 0, h equals to x and a equal to 0. Taking h equals to x and a equals to 0. And a equal to 0. We get what we are getting about f of x equals to f of 0 plus x by 1 factorial dash of 0 plus x squared by 2 factorial f double dash of 0 plus 1 plus x power n by n factorial. Nth derivative of f of theta x. F of theta x. F of theta x. That means there exists at least a value theta in between 0 and 1 satisfying f of x equals to this. This is known as Maclaurin's theorem. Maclaurin's theorem. And the last term is known as same Lagrange's form of remainder. The last term is known as Lagrange's form of remainder. Just a modification of Taylor's theorem is nothing but Maclaurin's theorem. Now, Maclaurin's series. Maclaurin's series. In the above Maclaurin's theorem, as n tends to infinity, remainder Rn equals to x power n by n factorial and the derivative of theta x tends to 0, not equal to 0. Some of you have written equal to 0. Should not write equal to 0. Okay. Steve Jobs knows that he will die within 6 months with a chronic disease called cancer. But even though he has done a lot of things towards the company that he founded, co-founded, Okay, so within that 6 months, he has done a lot of work in order to what you call found an ultimate technology like iPad or Apple phone and all those things. So everyone has to think that their life has an infinite, so that we have work. So here x4 n by n factorial f derivative of f of theta x tends to 0. Okay, when it reaches to 0, we don't know, but it reaches to 0, that's why we get infinite series. So Taylor series and Maclaurin series both are infinite series. So what is Maclaurin series? F of x equals f of 0 plus x by 1 factorial dash of 0 plus x squared by 2 factorial and double dash of 0 plus so on. That's it. And so on. Yes, unit. Okay. So Maclaurin series is f of 0 plus x by 1 factorial fraction 0 like x square by 2 factorial combination 0 plus x cube by 3 factorial combination of 0 and so on. I'll give one simple expression, the remaining we will discuss tomorrow in the next class based on it. So based on this Maclaurin series, we are writing the expansions of e power x, sin hx, cos hx, and all the inverse trigonometric, hyperbolic, logarithmic expansions. For example, this is asked to indicate e power x. But if you consider f as e power x, f dash derivative is also e power x, second derivative also e power x, third derivative also e power x. Now e power f of 0. F of 0 means f of e power 0. E power 0 is 1. Next. F of 0 is 1. F dash of 0 is x by 1 factorial negative 1. F double dash of 0 is also 1. X square by 2 factorial into 1. If you want to write x cube by 3 factorial into 1 plus so on. That is e power x expansion. This was asked once and again. The expansion of e power x, it was asked. And even if you want, you can write for sin x. Sin x. If f is sin x, f dash is cos x. F double dash is minus sin x. F triple dash is derivative of sin is cos. So minus cos x. Fourth derivative of f is derivative of cos is minus sin, minus of minus sin x. And so on. Now, substitute in this f of 0, sin 0 is 0, x by 1 factorial, cos 0 is 1, next sin 0 is 0, double derivative 0, next minus cos x minus 1 plus x cubed by 3 factorial minus 1. The next one will be fourth derivative is 0 and fifth derivative is cos x. So x power 5 by 5 factorial into cos x, cos 0 is 1 plus 1. So sin x expansion is x minus x cube by 3 factorial plus x power 5 by 5 factorial or x power 7 by 7 factorial plus so on. That is sin x expansion. Sin x expansion. For hyperbolic functions, this was also asked in the debate. For hyperbolic functions, all are positives. Sin hx will be simple to remember. Sin hx will be x plus, all are positive, no negatives. X cube by 3 factorial plus x power 5 by 5 factorial plus x power 7 by 7 factorial plus so on. In the similar manner, try to write for cos x, cos hx, tan x, and so on. Try to write. We will discuss tomorrow how to write those. Okay. So now you may take leave after noting this. Everything is clear? Yes. Okay, you can take leave. We will continue tomorrow related with the problems, related problems.